Thank you for coming. My name is Michal Hrusecky. I work for a company called CZNIC, and I'm working on project Turris. And today I want to talk to you about what we do and why we do it, and hopefully about something that you can do that will be fun for you, will bring some help to us, and in general will improve the world. So I will start with who we are and what's this company that you never heard of. CZNIC, we are Czech top-level domain registry. So basically, we are managing .cz. So anybody who buys a Czech domain has to pay something to us. And as we are getting money from that, yeah, we could use it to buy Ferraris and stuff like that, but we decided that it would be much better to invest it and help the world. So in the end, by law, we are association of companies which all those companies are basically competitors, so the only thing that they agree is they need internet and working internet and better internet and stuff like that. So in reality, if we are set up like a non-profit. Basically, whenever we make some money, we have to invest it into something reasonable to help people. As we were getting money from the domains, and basically there is only so much money that you can spend on reliable domain registry, we started doing some interesting projects. First one that actually makes quite sense in terms of what we do is that we are doing not DNS server and resolver. Both are open source projects. And we started doing those, and in the end we got some contracts for support, and we started making money out of it as well. Again, we are developing BERT, open source BGP routing daemon, and we also provide contracts for that, and it also makes money. So we do other activities to burn money, but like we are publishing books, and we are doing education series in TV, trying to teach people how to behave responsibly online. And one thing that we also do, partially because of money, but mostly because it's a responsible thing to do, is we are managing Czech national CSIRT team. That's a Czech national team that handles security issues in IT and coordinates with other teams inside companies and inside other countries. And at some point, we got into business of making open source Wi-Fi routers. I will talk about that later, but that's the area that I'm from. So I'm in the security track, and I promise that I will be speaking about catching the bad guys. Right? So, bad guys. Internet is a dangerous place, and whenever you are online, and if you are reachable from the outside, you are not hidden behind some firewall or net, you are under attack. Take a look at the logs at your server, and you will see attempts all the time that will try to figure out a way how to get inside. I took a look at one of my servers that I run for my private use, and basically in SSH you will see that there's plenty of people trying to log in, trying to guess some name and password. Sometimes there are even people trying to talk to SSH with some other protocol because they think that there might be something else running it. If you are running web server, you will see that there is plenty of people trying some weird URLs, like WordPress login and trying to find PHP myadmin and stuff like that. And if you are running SMTP, then you get plenty of requests to log in, and also plenty of requests to relay emails that are obviously some spam. So what can you do to prevent all those people that are trying to attack you somehow? So the first and obvious thing that you can do, if you get logs full of attackers that are trying to do something to you, you already know about them, right? You know that they were trying to do something bad. In the logs, you have IP addresses of those bad guys, so you can block them. There is a software to do that. It's called Fail to Ban, and it's a really old software, probably part of every distribution that you might be running. And what this software does is basically what you would do manually. It tries to go through your logs. It watches for the new entries, the entries like the ones that I showed you previously. And it supports some regex matching. It tries to figure out what's the IP of the attacker, count some points, and when the same guy tries to log in for the third time, it will create a firewall rule that will block him. It's not that hard to set up. There are even some rules prepared for typical configurations like SSH, Apache, Nginx, and stuff like that. But the tricky part is that you have to set it up, and that whenever you change your log format, you have to make sure that the regex still matches. And if you are debugging something, then you probably want to change the verbosity of your logs. And sometimes you change the format and regex no longer works. So you have to be a little bit careful with that. But yeah, that's a really simple service. It helps you with some stuff. But how you can be even meaner to those attackers? What you can do as a next step is honeypots. That's much more fun. What honeypot is that it pretends to be vulnerable system. One nice example of honeypots that are quite common is SSH honeypot, because as we saw, there is plenty of people trying to guess your password and trying various combinations of username and passwords. And what SSH honeypot does is, based on your configuration, it will allow some of those easily guessable username and passwords to go in. So attacker is happy. He found a vulnerable system. He gets in, and he can try to look around and play with it and install some malware and try to attack somewhere else. But what he doesn't know is that it's not a real system. Typically, those honeypots doesn't support every command that the attacker might want to try. They have pre-recorded answers to some of the commands. And if he tries something that honeypot doesn't know what to do, they do something like core dump and pretend to be broken system. So the output of honeypot is that you will get, the attacker will spend some time playing with the honeypot. Unfortunately, it's mostly bots, so you most likely wouldn't waste human time, but sometimes it happens. I've seen some session that somebody recorded where the attacker didn't manage to log out, and he told that he already logged out, but he was still in honeypot and he was trying to do something else and found out that his home directory is missing and looked really scared. But that would be really, you will be like really lucky if you found a real human attacking you. And the tricky part about honeypot is that you have to set it up somehow. You have to figure out which combinations of password and logins you want to allow in. And you want to figure out what commands does your honeypot actually support. And then you get some sessions recorded. And what would you do with that data? Well, it's fun to look at it. But if you collect 100 people a day, then it's no longer that much fun. And because quite some of them would be same. And you will probably end up with just piping it to fail to bind anyway. So some generic stuff that you might want to do, even without anything what we do at our company, is set up fail to ban on your servers and hook virus logs into it to make it harder for attackers. And if you set up a honeypot, you might want to put it into fail to ban somehow as well. But then nowadays, the popular way to deploy services is microservices. So you don't have just one server nowadays. You probably have a cluster of plenty of servers. And then you have to figure out a way how to distribute this data across your servers. So there is something that we can help you with apart from the honeypot part. So how Turris fits into all of this? I will start first with what Turris actually is. How our project started was one big question. As I mentioned previously, our company runs a Czech national CISR team. And those guys were wondering, yeah, if you have a server and you are running web pages there, if you are running SMTP there, there is plenty of traffic going in both directions, and we are clearly a target. There is plenty of people that probably wants to attack you because you are a nice target. But what about home users? Still, there are plenty of home users that will get public IPv4, even though there are no IPv4s anymore. But ISPs have them, and they will give them to even home users. So is somebody attacking those people that are not running any web server? Their IPs are not in any logs, not in any DNS records, nowhere. And if somebody is attacking them, how they are attacking them? So we decided that we wanted to know the answer to all these questions, and we created a project to do that. We created a hardware security probe that we give away in Czech Republic for free. And the only condition was that those people will connect it to their network. It will be their first device that will be on the network from the ISP point of view. So it will have that public IPv4. And they will allow us to run some traps for the attackers on it. And it looked, to make it more appealing, it looked like a router, and it was actually working as a router as well. So, and since we were doing some interesting hardware, we did software also the correct way, like gave people root account and provided security updates and made everything open source and stuff like that, as any decent company should do. So we gave it away. And after a while, people started coming and asking that they would like to have more, and they would like to use it in companies and stuff like that. So in the end, we ended up with creating some commercial routers that we started to sell because obviously we found out that there is a market for people doing routers that are open source and secure and have security updates and stuff like that. And we still kept the security program on those, but we made it opt-in because if people bought it, they deserve to have some privacy by default and decide whether they want to help us or not. So we have new routers, and recently we actually made them available in US as well. So what we were doing was we were doing everything open source. We have plenty of software in our repositories. And one thing that already was at that point of time, something like 6 years ago, not that often, not that common, was that we were doing security updates for our products after we sold it to people. And we put in DNSSEC validation. That is even nowadays not so common. And we allowed people to play with that. So what's the security features that I was speaking about, and what were we doing actually? This is some simple schema of what we are doing even nowadays. Basically, we have a bunch of routers that are connected to our network. And whenever there is some attacker trying to attack one of our routers, the router will send us all the information that it knows about the attacker. And if we found out that he's evil, where evil is a little bit more complex question, then we send the updates to all our other routers, and they will block him on a firewall. So something similar to fail to ban that we spoke about earlier, just with the thing that the difference is that we are collecting data not just from your one machine, but we are collecting data from all the routers participating in this program. And whenever we found somebody, we distribute all this information back to everybody again. So some collaborative distributed fail to ban. So we started with the security program that I spoke about. And back in the days, we have some software that was doing that. We knew that we have a limited number of routers that we gave away. We knew that there is exactly 2,000 probes, no more, no less. And that all those probes will have always everything enabled. They will always update. And it was really a simple world. So we made a simple software and made sure, and actually made everything hard-coded somehow. And because we were unsure what we will do with the data, we put everything into database and then everything fetched from the database, and everything was evolving around the one central database. We got out of there quite a nice gray list with all these attackers that we found. We collected some information about them, and we started playing with the data that we collected. And we found out that some of the data that we are collecting are quite useless. On the other hand, we found some data that we would like to have in more details. And one important thing was that we got feedback from our users of our probes. And that feedback was basically that they want to buy those routers. And we responded to that by making something that they can buy, which resulted in increase of our users. So our design for fixed amount of probes weren't enough, and we started well, the whole system started slowing down, and based on the simple design that it was designed, it didn't scale up. So we were unable to make divide the load between various servers. So we knew that we have to do something with the software. And apart from that, we found out that when we were speaking about what we do and what we found that some people were really eager to help us and wanted to run our probes even not on our probes. So they wanted to help us collect information about attackers, especially since our colleagues in CSER team were doing some security research and were trying to look into the attacks that those attackers are using and trying to identify some botnets that were doing the attacks and stuff like that. So they were doing a really nice job with the data. So people wanted to provide us with more data, but yeah, they have servers running somewhere and wanted to contribute with data. So what we did was we created a service called HAS, Honeypot as a Service. What it is and what it does is basically, as we spoke about honeypots, it's possible to run honeypot on your server, but you have to figure out the configuration. Probably over the time you need to keep it updated and even change the configuration. And then you will end up with a lot of sessions that you locked, and you have to figure out what to do actually with all those sessions. So what we offered people was that they can use our servers to run the honeypot and simply just direct all the attackers to our servers. We will keep our honeypot updated. We will change the configuration of the honeypot when needed. And we will use the logs to identify attackers and new trends. And we will share it inside the security community. And apart from that, even if somebody escapes from the honeypot, which in theory can happen, it's just a software. And yeah, no software has no bugs. So even if somebody escapes from that honeypot, he will escape on our servers, so no danger to you. So basically how it works, attacker tries to attack your server, but there is a simple proxy that will forward all the communication to our server. Attacker thinks that he managed to break in to your server, but he actually managed to break to honeypot, but not honeypot on your server, but honeypot on our server. Installing honeypot as a service is really easy. We have a package called HAS proxy. It's available in some Linux distributions, and in worst case, it's available in pip. You just install it, you register on our website, and then you can simply start it and wait for first attackers to come in. What you will get in the return, apart from the good feeling that you basically messed with some attackers and make their life harder, and that you contributed to security research that we are doing, you will get some statistic on our website. We have a map that shows the activity of attackers that were caught into the honeypots that our community is running. And for your own honeypots, you will get also a list of attackers that tried to attack your honeypot with some geo information, and you can see what how many commands they tried to run and stuff like that. And you can even inspect individual sessions and see what went through. You can see what commands they were trying to run, and you can see whether the command actually returned correctly, or if honeypot were unable to figure out what to do and did something like pretending to be broken and stuff like that. So that helps with collecting data about people trying to attack on SSH. And you can install it on any server that you have. And it solved, partially solved, one of the feedback that we got from our security program that people would like to help us collect those data. We found out that plenty of people were really interested, and it started to grow. And we had to address the other issue that was that our servers were unable to keep up with new Omnias that we were selling. So we wrote Turris Sentinel. That's our new software that is replacing the software we used for collecting those security data. We rewrote it from scratch, and when we learned from the lessons that we learned from the previous system, it started. We designed it distributed by design, and it contains all the stuff that we built into the previous system. One of the interesting part is not only the honeypot, but we also created something that we call minipots. It's basically simple services that are pretending to be vulnerable, like telnet or HTTP server, but it doesn't emulate the whole system. It just, in case of telnet, it asks for login and password, and then closes the connection. Similarly for HTTP, it just waits for the GET request and then closes the connection. So really simple. That simple means that there should be much less possibility of any bugs. So those are services that we are running even on people's routers. We are collecting firewall logs, and we still have the distributed firewall that I spoke about before. It's much faster already on the existing hardware, but we are able to scale it up to various servers. And when we were redesigning it, we also made sure that it's not that tightly coupled with the hardware that we gave away previously. The idea is that we want to gradually open it, similarly as we did with the HAS, because the HAS helped us to figure out that people are actually interested in sending those data to us and helping us catch the bad guys. So this thing still holds, but in reality, underneath, it's quite complex. Basically, we have some minipods that are running on the router. We have a HAS that is also running on our routers, and both data from both of those services are getting sent to our servers, where we somehow enrich those data with GeoIP information, which ASN is it coming from, and stuff like that. And we do some analysis on top of that, trying to figure out, trying to distinguish between the real bad guys and you when you forgot that you are running honeypot on your home server and try to log in just once, and yeah, we don't want to block you. So when we enrich those data, when we go through all these analyses, at the end, all these attackers end up in some scoreboard where we count for each of them how bad they are. And when they are bad enough, we issue a warning that we distribute to our network of routers. For that, we are using some dynamic firewall client that is written in Python and uses 0MQ. And actually, that's one of the first things that we opened up. And as everything that I was speaking about, it is also open source. But this thing actually makes sense to run on your server as well. You can install it either via packages. We currently have some packages for OpenSUSE. And I built some packages for RPM-based distribution, but I haven't tested them because I run just OpenSUSE. And it's a very simple Python script. You can get it from the URL up there. We also have systemd and firewalld definitions. So it can integrate nicely into firewalld and systemd. And then you can just start it once you install it. And what it does, it is downloads a certificate that we have on our HTTPS server, then uses this certificate to establish 0MQ connection to our server, and waits for the notification. First notification it waits for is a full list of current bad guys. Then it updates an IP set that it created, and keeps that IP set in sync what server has. Because server, apart from periodically issuing full list of bad guys, it also sends the differences against the previous list. So you can use this to get real-time updates about who we found to be bad. Currently, this new system that we are working on is still kind of experimental, so we don't have that much data in there. So even the list of the bad guys is quite small, and the statistics might not be really representative, but we hope that it will grow over the time. So some statistics out of the new system, which, as I said, are not really representative, but still interesting and shows what we are trying to figure out in the end. First thing first, there is a website that you can go to and take a look by yourself. I will show it at the end. And we also made some graphs about where did we find the most attackers over some short period of time from, yeah, as I said, quite small data set. So who's attacking us the most? Which country is it? No, actually, it's United States. But China is second and Russia is third. We wanted to take a look into those data and how it actually differs. So one example that is we have Telnet and SSH connections. So who's using what? So for Telnet, China is the #1. And United States are even third. So Telnet is not popular among attackers in US. What is popular is SSH. There US is first. So it looks like US attackers tries to use newer technologies. But yeah, then we thought that this is actually kind of unfair comparison because yeah, China is a really big country with billions of people. US is not so small as well. So we were thinking about let's divide it by number of people that the country has. So we see how bad are citizens. So then we found Denmark. If you want to hire an attacker, then in Denmark you have the highest probability with a random person on the street. And yeah, the question is, yeah, basically, this is just for fun most of the part, because as I said, we have. Yeah, because as I said, we have just currently quite small user base, and one of the question that the guy there was asking is where are our servers located. Yeah, we have most of our probes in EU and most likely in Czech Republic, so that's another thing that will skew the results a little bit. But yeah, don't take those graphs so seriously. As I said, we have just yeah, not that much of probes now. Once we get more probes, we will get better data. Yeah?
Have you done any calling of the IP addresses based on command and control systems, botnets, and remove those? Because most of the hackers are going through cutout servers, maybe multiple cutout servers if they're smart. Can you repeat the question?
Yeah, the question was whether we filtered out some command and conquest centers. And no, we didn't. Basically, we are looking at the data that we get from our systems, and that's well, basically the goal of this system is to collect IPs of people that are attacking you, so we can block them. And even if it is a command and control center, yeah, we still want to block that. And yeah, one more thing that I wanted to show, and we played with was, yeah, when we were trying to, well, basically when we eliminated the US and China because they are big countries, but there's just small communities that are behaving badly. We did something similar about, we also tried to look at GDP and divided it by GDP, so where you get most attacks for GDP, and we got Denmark again, but then it differs, like Gambia, Palestine, Seychelles, while most evil persons you will get in Denmark, Cayman, Singapore. But yeah, if you want to optimize based on money, then try Denmark again, or Gambia, or Palestine. So, some fun for the end, and few pointers that you might want to look at. First link is our view of Sentinel data, the data that we are collected. I will show you that in a minute. Second one is web page about our honeypot as a service. If you want to run it, we will be really grateful to you. And then some stuff about Turris project in general, and of course link to our sources. So, how does it that Sentinel view look like? We have the map of attackers. We can see how many events. Yeah, I will. Oh, and one thing that I learned yesterday, the most important feature of all, we have a dark mode. So yeah, you can browse country by country and see how many events we received from various countries. You can see attackers' activity during the time, and we also have some top passwords that people are trying. If you are interested in the passwords, we have a separate page for that. And we have even top usernames that they are trying. And even top combinations of both. So if your password is on this list, I suggest you should change it. Apart from that, what we are doing again is we are publishing some gray list of data. So it's just a CSV with bad guys that we found. And when the bad guys is behaving good for long enough, we will take it out again. So if you are running some, for example, mail server, you might want to use it as a gray list and add some spam penalty for those IP addresses. And for the honeypot as a service, when you log in, you can see a list of your devices that are collecting data, and you can take a look at sessions that were collected by individual devices. As I shown previously, you will see who was attacking it, what username and password they used, and you can take a look at what they were trying to do there. The interesting part is that quite often there are information like download this software from somewhere and then run it, and that's what our security researchers are interested in. They take a look at the software, try to figure out what it's doing, and trying to figure out whether it is a new botnet that is trying to spread, or whether it is something old that they already knew. So, thank you for your attention, and now it's time for your questions. If you have more questions later on, we have a booth this year in Expo area, so you can drop by and talk to us about what we do or about our routers. Thank you. It says that battery is dead.
It is dead?
Battery.
Try it, because otherwise we can't, or you could just repeat it.
Test.
Is it dead?
Yeah.
Just repeat the question.
Yeah, I will repeat the questions if you have some. Yeah.
So you're doing basic checking of IPs, that one's attempting to get into, Xbox or its services. Have you tried with all the information? I know it's a small data set, but have you tried putting that into something for known compromised systems? Because for a lot of these, it looks like they're botnets and they're known variants of botnets. So you can use that to build better metrics. This is a compromised home computer. This is IoT and protecting it.
Okay. The question was whether we try to match these IP addresses that we found with already known compromised systems, right?
Well, types.
Types. Yeah. Yeah, that's actually something that I cannot answer because I don't know. Basically, how it works in our company, I'm from the Turris team, which develops the router, develops the software, and we provide the data. Then we give this data to our security researchers that do exactly that. They take a look at what this data means, whether they correlate with some known attacks, whether they are already on some blacklist and stuff. What we are trying to do with this data is we are trying to make it as automatic as possible to get them on the blacklist as soon as possible, to have them on our firewalls. Is it answer enough? Okay, thank you. Another question? Yeah?
I know IPs that are part of mostly the cloud services that may be shared, right? Like it's a dynamic IP, I don't know, mail server spins up and then it's on.
Yeah, so question is how we handle dynamic IPs. And basically, yeah. As I said, what we are trying to do is to get people on our blacklist as fast as we can. So if they appear somewhere, we are able to distribute information about new attacker within a second. And the other part is if it's dynamic IP, it means that it might change. So the attacker will move. So the part that we are able to put him on the blacklist within the second solves the problem that he has a new IP. And the other part of the problem is that the old IP is on the blacklist, but for that, for every IP that we have currently on our blacklist, we keep the score. And if it doesn't attack anywhere, we will start lowering the score. And after a while, we will remove it from the blacklist because it might be just infected computer that got reinstalled, or it might be dynamic IP or something like that. That's how we handle that. Yep.
You produce the list of IP addresses and the scores in a kind of format that I can download and put into my Elm stack and try to help me, rank
Well,
about specific attack
we don't produce a simple file with IP addresses and the score. What we produce is a simple file with IP addresses and the reason why they are on the list. So yeah, yeah, you will see whether they are on with every IP address on our gray list. You will see that whether they are there because they logged into Honeypot as a service, whether they did the port scan, whether they tried to log in over the telnet, whether they tried to connect to Honeypot as a service but didn't issue any commands and disconnected right away. So you will see what the IP address was trying to do and why is it on the blacklist. But you wouldn't see the internal score. I'm not sure whether the score might be available if you use the API. But yeah, the API that we are using to distribute the firewall is really simple. The whole dynamic firewall thing is something like 200 lines of Python. So it's really easy to integrate into different systems. Okay, any other questions? Oh, yeah. Whether we are thinking about any other honeypot apart from SSH, well, we are not thinking about honeypot as such, but we are thinking about the minipots that I mentioned, like telnet that will just ask for credentials, or the web server that is just waiting for the first GET. We also have some SMTP minipot, similarly simple. It will not accept any mails and stuff like that, but just wait for identification of the attacker and maybe some credentials again and stuff like that. That's the stuff that we currently run on the router, but we are trying to figure out a way how to make it available even for the servers. So in the future, we hope, well, we started with a dynamic firewall because that one is easy and we don't need to, well, basically we are sending the data and you decide how much you trust us and how you will incorporate it into your network. But for the collecting data about the attackers, we have to decide how much we trust you that you don't fake data. So over the time, we will make the minipods available on the servers as well with telnet, HTTP, SMTP, and other services. Okay.
Now that you guys are selling your hardware to different consumers around the world, are you running into any issues where maybe ISPs are you having any conflict with internet service providers, possibly because they recognize services as being vulnerable or blocking mail?
Yeah, I understand. Yeah. Question is whether we are running into troubles with ISPs because we are basically running something that looks like a vulnerable system. As far as I know, surprisingly, nobody complained about that yet. What we get complaints about from ISPs is because, as I said, one of the things that we do to improve security is we do DNSSEC validation. And what we support is running full DNS resolver on your router, because quite often DNS resolvers of your ISP are broken and even break DNSSEC and sometimes break various other requests and stuff like that. So we support running full resolver on your router. And when people do that, some ISPs complain that there's too much DNS queries going on, and they are not going to our DNS servers, and that's suspicious. You have some viruses. So that's what we get complaints about. But I haven't seen any issue when somebody would be, when ISP will be complaining about open ports and pretending to be vulnerable system. They probably check much more what's going from their network out than what's going from out into their network. Okay, any more questions? No? Then thank you for your attention, and if you have more questions, feel free to drop by at our booth and talk to us.